Welcome to video 4 of the series of 5 videos. Today we're going to be improving the model that we created previously to add parameters that would allow us to grade or classify our NDVIs into classes that we can compare between seasons. So I'm going to open the NDVI model that we created previously for the before NDVI. From the model you can see that we're computing an NDVI image, which basically gives us a range of values from -1 to 1. But we cannot compare those values with another seasonal image that is being computed from the after NDVI. So I'm going to add a criteria operator that allows me to define different categories for my NDVI. By double clicking the operator, the criteria definition table opens, and I'm going to define 6 classes for this NDVI. So if I use the add, you'd see that a new row is added, and then I can define the class number. That's 1. I do the same 2 up until I get to the number of classes that I want. So there we go. So I've basically specified that I need. Now I need to define the conditions that need to be met for each value, for the values to be classified based on these classes. So I need to click on the classes and conditions for this criteria. So under the condition column, I click on the 3 dotted lines, and the condition editor opens. So the first criteria that I want is all the values that are less than 0, right, should be classified. That's the first class. The second class is going to have all the values greater than or equal to 0, and also being less than to 0.2 for my NDVI classes. I define the third class following the same criteria. So it's from 0.2 to 0.4. I repeat the process to define all the classes will remain. The default value will be 0, and then I click OK. So this operator takes in an input and takes and raster output as an output. So I'm going to add that from there to my output. So that means my NDVI value is going to be computed and get passed through this criteria, divided into those 6 classes, and define an output. So I'm going to do the same as well for my after NDVI. I will also need, this operator gives me an NDVI image. Same applies to this one. I'm also going to need to grade my NDVI value. So I'm going to create another output raster. Right. I'm going to call this output raster before NDVI. Right. So basically I'll be saving the NDVI image as a separate image. To save those NDVIs separately as well as images that I can go in and view. I'm going to add output ports, port input. This allows me to define my graphic user interface. So these ports will be the ports that the user would edit. So I've defined our 2 NDVI images. The 2 NDVI images are being loaded inside the CVA model that calculates and a magnitude. So I'm going to break this model. The reason is you can define further classes for the distance and for the direction I'm going to paste them here, and I can do away with this model. Okay, so direction, we've completed a graded NDVI here. So I'm going to do the same thing as well. It's going to be after image, subtract my before image, and I would also want this to be defined into a criteria. And the criteria for this is very simple. Adding that. I can rename this one to direction underscore criteria. Right. So what I want to identify there is pixels that have a negative direction of change, pixels that has a positive direction of change, as well as pixels that don't have any change over that period of time that we're analyzing. So I double click, that means I have three classes that I'm going to be defining. So I've defined my three exclusive classes that I'm going to create my output direction image onto. So this allows me to do, so after calculating our direction, we also need to calculate our magnitude. So I'm going to use the distance operator, which is based on the Euclidean distance. It's also going to take my input, my after NDVI, and my before NDVI to calculate the distance, basically, which is the amount of change or the magnitude of change. All right. So I can also do the same process to define my classes of change. It is also important to know that our distance is being calculated based on the classified NDVI values. So I might need a separate image, raster output. I'm going to create these four outputs. So I'm using lens at 7 for the before image. Therefore, I'm using band 4 and band 3 for my near infrared and red band respectively. And for my after image, I'm using lens at 8 image, thereby using band 5 and band 4 for my near infrared and red band respectively. And note that the additional outputs that we've defined are also listed at the bottom, my before NDVI. By default, all the files will be saved in my default directory that I've defined. So I'm going to call this one before underscore NDVI. Yes, I'll remove that previously calculated. And I click run to run my model. I can open the output images that I've created to preview them. So I'm going to add file open outputs. So I created after NDVI, before NDVI. The first image that you're seeing is a grayscale image of the after NDVI. Class 2, so I can view the attribute table for that so that I can identify the three classes respectively. Class 1 is basically negative change direction, so I can make that probably red. Class 4, so class 1, class 2, value 2 is basically pixels that had no change. I leave them on gray, and the ones that have a positive change, I'll make them green. So basically almost all of my image. Same applies to my magnitude. Term. So the range of values that I have in my magnitude, they range from 1.4 to 7. So what I need to do is I need to define my classes of change, basically the direction of change. I already see that there is a majority of positive change. So now I want to see how much of that is negative. By how much did it change negatively, and by how much did it change positively. So I can zoom in to view my classes better. So the values that I wanted to see is this. So I note these values down, 1.4 to 7. So I can go inside my model, and this is where I want to add another criteria. Double click on the criteria, and I'm going to call this magnitude criteria. Link it back to my output. Now I can define the criteria that I'm using, that I want to define. So for my magnitude of change, we're going to define 4 classes of change. So I'm going to add the placeholder, class roles. So class 1, class 2, class 3, class 4. Class 1, class 2, class 3, class 4. Then for my class 1, it's going to be, so we know that the range of values that we have, the range from 1.4 to 1.7. So I'm going to say all the values that are less than, alright, so these are the classes that we have. So basically to be no change, low change, moderate change, and high change. Those are the classes that we have defined. Expand the model so that I can see it better. Right. Then I can use the auto layout so that it arranges properly for me. Right. I can then add these two into their own submodel so that I can develop that further. Name this one direction model, and do the same as well for this one. To be the name magnitude model. So as you can see, our model is improving as we go, both in performance and in the quality of the outputs that we're getting, as well as in the layout and design of the model. So now I can click run to create my outputs again. Okay, because since I've done it previously, I'm just going to accept, delete, basically overwrite the previous results, then click OK, and the model reruns again. So to add my direction, my before and my after images. Fit everything frame. So the last image that I have on top is my magnitude image. Right, that is the 4 classes that I've defined. Okay, no change, basically around the water bodies. So I can just make some blue so you can just see that. Right, that way we have a very low change magnitude as expected. So our model already is making sense and it's looking calculating proper results for us. Class 2, we say this is probably no change. I can make this probably a bit of yellow. That's our low change. And then in Erdas where we have moderate change, I'm going to make this gold or orange. Right, and then in those areas where we have highest change, I can make them red so that we can see that. So those are the 3 classes that we have defined for our magnitude of change. Right, we can do the same for all these other classes. Ideally, obviously, these results would look, as you can see, they would all look prettier if they are colored. So that will be the focus of the next video, how to add colors to these models and improving the calculations further. Right. So I'm just going to clear. Let's remember to save a model every time you make your changes. So I'm just going to file save as, save model as. So let's just say CA model version 4 for video 4 that we've just ended on. Thank you. So this ends today's lecture or today's demonstration on how to improve our spatial model. Thank you.